Hello friends. So in the last lecture we have seen about the eutectic system. So we are just looking for the various kind of that phases in equilibrium diagram. So when we are going for that equilibrium diagram of iron carbon, or we can say Fe3C, you can be able to easily understand the different kind of that phases. So these are the very supporting lectures for those particular phases. So you just try to understand those terms. So in the further lectures, you can be able to understand what are the different kind of that phases in Fe3C diagram. So we'll start with our contents. So in the last lecture, we have seen about the eutectic system, and in this particular lecture, we will focus on the different type of the phases in the eutectic system, and then we will just go for the next content, that is the partial eutectic system. So these two things we will try to cover in this particular lecture. So this is the diagram which shows the different phases in the eutectic system. So first of all, you just try to understand what are the different type of that phases. So generally there are the three phases in this particular diagram. So here you can be able to see this particular diagram is divided by the three lines. So this is the first line. Here it shows A plus eutectic. This is the second line. So in the last lecture we have covered this E point is the eutectic point. Okay. So this diagram already we have explained in the last lecture. So those who are listening this particular lecture, just go for my previous lecture so you can be able to understand this. What is this particular phase diagram? So we are just continuing this particular part with this lecture. So this E is the eutectic point, and again this particular line which shows the phases of eutectic plus B. So I can be able to say that this particular diagram is divided into the three parts. So the part one is the A plus eutectic, part second is this only line, that is the eutectic, and again this is the part 3 eutectic plus B. So A and B are the metals, two metals that we have taken as an example over here. So A and B are the two metals. So this particular diagram is divided by the three parts. Now what are the three parts? First is the cooling of hypoeutectic alloy. Okay, so this term or this particular section, this is the cooling of hypoeutectic. So it is called as a hypoeutectic. Okay, then second, that is the cooling of eutectic alloy. That is nothing but this particular line, cooling of eutectic alloy. Okay, and third, that is the cooling of hypereutectic alloy. Hyper. So here is the hypo, here is the hyper. Okay, so only the difference is that. So this will be the cooling of hypereutectic alloy. So we will just study about this particular line. Which kind of the changes are there? So this is the for the hypoeutectic, this is for the eutectic, and this is for the hypereutectic alloy. So I hope you have understood these three terms. What is the hypoeutectic, what is the hypereutectic, and what is the eutectic? So this is the hypoeutectic, this is the this is the eutectic, and this is the hypereutectic. Okay, now we will just go with the cooling of hypoeutectic alloy. So we will just discuss with this particular diagram. So now here just observe this particular phase carefully. Now just forget about this particular phase. Only you just focus on this particular phase. Okay. So you need to focus on this phase so you can be able to understand. Now from A to point 1 to 2. Okay. From point 1 to 2. There is no any kind of that phase change. Everything will be in the liquid. So 1 to 2, whatever may be the alloy present, that will be in the only in the liquid form. Okay. Now at point 2, okay, what is the happening at point 2? So at just below 2, the solidification starts here. Solidification starts just below the 2, and the metal A is separate out from the liquid with a further cooling. When we are just cooling down this, whatever may be the metal A is present in the liquid, that has been start separating. Okay, so at point from point 2 to 3, the metal A is start separating as when we are just lowering the temperature. Okay, so when the temperature is decreasing from point 2 to 3, the metal A is separating from the liquid. Okay, it will be continuous up to the 3, and the composition of liquid varies along the liquidus line. The C and the composition of A does not change because no solubility of B in A. So here the solubility of B is not there in A, so only the A will be formed. So at just below 3, the amount of A and liquid can be found out. So at just below the 3, okay, or whatever may be the below point 3, how we can be able to find out the amount of liquid and amount of A, that is by applying the lever rule. So here at the bottom everything will be in the solid, at above everything will be in the liquid. So below, whatever the solid is there, when we want to find out the amount of A, okay, so this will be in the solid phase. So with this particular lever arm, how we can be able to find out? By the lever arm. So amount of solid, that is the opposite arm, means 3E, okay, divided by whole line DE. And when we want to find out the amount of liquid, that is above this particular line, liquid is there. So opposite line means 3D or D3, you can be able to say D3 upon D. So in this way, we can be able to find out the liquid and solid. Now here, the cooling of eutectic, how it is forming. So at point 1, everything will be in the liquid, but when the temperature is goes below up to the point A, sorry, up to the point E, so it will be start forming the reaction. So at point E, we are getting these two solids, A plus B. So liquid is start converting into the two solids. This is the eutectic point. We have explained this particular point in the last lecture. So the reaction is liquid is separating out into the two solids, that is the A and B. So this is the eutectic point. So in the eutectic point, the both metals are start converting into the solid phase. Okay. Then next is the hypereutectic. So in the hypereutectic, at point 1 to 2, no changes are occur. Then 2 to 3, now B is separating out. Here A is separating out. Similarly, in this particular phase, B is separating out, okay, from the liquid. So at point 3, everything is start converting. So B is just starting converting into the solid phase. So we are getting the metal B in this particular phase. Now how we can be able to find out the amount of liquid in this? So liquid is above this. So our opposite is 3F divided by EF, and the amount of B, that is opposite line, amount of B, to find out the amount of B, that is E3. So here is everything will be in the B. Here everything will be in the liquid. So opposite is 3E divided by whole Fe. So I hope you have understood these three phases. Now we will just go with the next system, that is the partial eutectic system. Now what is the partial eutectic system? That is two metals which is completely soluble in the liquid and partially soluble in the solid state. So whatever may the metals are there, that should be a completely soluble in the liquid and it should be a partially soluble in the solid state. So in the previous case, for the eutectic system, they are just soluble, okay, that is the completely soluble in the liquid and completely insoluble in the solid. But in this particular partial eutectic system, it is completely soluble in the liquid but partially soluble. Okay, only partial solubility is there. In the previous case, no solubility in the solid state. But here The partial solubility is there in the solid state. So this is the phase diagram, general phase diagram for the solubility. So we will just understood this particular phase diagram with the contents. Now when it is the partial soluble, okay, so this A and B, when it is partial soluble, that phase diagram is slightly changes. Okay, so these kind of that curves are occur. Now what is this partial solubility? We will just see. In the previous case, okay, these are the straight lines and only this particular curve is there. But now when partial solubilities occur, this curve is generated. Okay, that is CDH, and here GFK. This curve is we are getting, and this alpha term. So what is these terms that we will just see. Now here C and G are the melting points of A and B metals. So you just start understanding this. So C and G are the melting points. So we will just focus on the C and G, C point, G point. So these are the 2 points, melting points of A and B metals, of A and B metals. So A and B metal it is there, C and G are the melting points. Okay. Then liquidus line is CEG and solidus line is CDEFG. So liquidus line is CEG, that is CEG is the liquidus line, and solidus is CDEFG. This is the solidus line. So now we have just understood liquidus means above that particular line everything will be in the liquid, and solidus means above below this particular line everything will be in the solid. So we can say these are the boundary lines. So alpha is the solid solution of B in A. Now this is very important to understand. What is alpha? Alpha is the solid solution of B in A. Means this is the A alloy. Just see, A and B are not 100% mixed in the solid phase, but it is partially soluble. Okay, not everything will be soluble, partially soluble. So alpha is the solid solution of B in A. Solid solution of B. Whatever may be the B is, it is there, no? So in the A, whatever may be the solubility is there. So B in A. Similarly, what will be the beta then? Beta is solid solution of A in B, because this will be the B phase. So solid solution of A in B. So whatever may the metal A is there in B. So don't confuse in the beta and B term. B is the metal, beta is the solid solution of A in B. Now H and K, this indicates the room temperature solubility of B in A and A in B respectively. So H, it is the room temperature solubility. Okay. Here this will be the room temperature. So H is the room temperature solubility of B in A, and K is the room temperature solubility of A in B. Okay. In metal A, in metal B. Okay. Room temperature solubility. Now D and F indicates the maximum solubility of B in A and A in B at eutectic temperature. So B, these two terms D and F. So this point D and F, this indicates the maximum solubility. Maximum solubility. D is the maximum solubility of B in A at eutectic temperature. So this will be at eutectic temperature, and point F, this will be the maximum solubility of A in metal B at eutectic temperature. Okay. So curve HD and KF indicates the solubilities of B in A and A in B. So this curves HD and KF indicates the solubilities of B in A and A in B respectively as the temperature rises from room temperature to eutectic temperature. So this is very important. Here the temperature is rising from room temperature to eutectic temperature. So this curves will be forming. So when we will go from room temperature to eutectic temperature, this will be gives the solubility of B in A initially, and then here A in B. So these curves are called as a Solvers line. So these two curves are called as a Solvers line, and E indicates the eutectic composition and eutectic temperature. So whatever may be the E, it is there, that is indicating, this E is indicating the eutectic temperature and eutectic composition. So here this particular diagram is divided. This will be the alpha plus beta, A and B. So alpha plus eutectic, beta plus eutectic. Now we will just take one example. Okay, so this is the diagram. What example we are going to take? This is the diagram for that. Now here only we are just considering about the partial eutectic system for silver and copper. So silver, that is indicated with Ag, and copper, this is indicated with the Cu. This two things we already known for this. Now here this everything about this particular diagram. So above this everything will be in the liquid. So this will be the alpha phase, this will be the beta phase. Now in this particular diagram, whatever may be the exact contents, that key points, the notations at this particular key points, the temperature or composition, that is missing. But here with the example we are just telling, so this point D, which is having the 8.8% Cu, at this particular eutectic point the Cu percentage is 28.1%, and at this point here, this particular point is indicated with the F in this particular system. So here at point F, the copper is 92.1%. Now when the copper is 92.1%, what it means, the silver will be how much percentage? 100 minus 92.1 means almost 7.9% silver will be there. Now here when we are talking about copper is 8.8%, what it means, silver will be remaining 91.2%. So at 8.1% copper means the silver will be 71.9%. Okay, so in this way we can be able to explain this particular diagram. Okay, now we will just go with this content. Now the above diagram phase figure is, it is just a phase diagram of Au, Ag and Cu, that is silver and copper. Now the melting point of Ag and Cu is 961 degrees Celsius, 1083 degrees Celsius respectively. So the melting point of Ag, here is the melting point of Ag, which is 961, that is 961 degrees Celsius, and melting point of copper, that is 1083 degrees Celsius. Okay. Now the eutectic temperature, that is 780 degree. Now this will be the eutectic temperature. So this is the eutectic temperature, is at 780 degrees Celsius. So both, what is the eutectic? What is the meaning of eutectic? In the previous lecture I have explained this. Again I will just tell you, at eutectic point both the metals, okay, this is the just common point where both the metals will be start solidifying. So at 780 degree Celsius temperature, both the metals will be start separating out from liquid to the solid. So two solid phases, that is solid 1 and solid 2, that is solid of Ag and solid of Cu you will get with this particular diagram. Now we will just go further with the stages. Now eutectic composition, that is 28.1 degree percentage of Cu. So what is the eutectic composition? 28.1% Cu means 71.9% silver. So eutectic temperature is 780 degrees Celsius. Eutectic composition, that is 28.1% copper means 71.9% silver. Now the maximum solubility of Cu in Ag, that is alpha solid solution. So maximum solubility here, this will be the maximum solubility of copper in silver. So how much? that is 8.8%. So 8.8% copper can be soluble in Ag, that is silver, at eutectic temperature. Okay, now the maximum solubility of Ag in Cu. So when everything will be in the copper phase, how much percentage of silver can be soluble in it at eutectic temperature? That is 7.9% Ag. Okay, so when everything will be in the copper, so maximum 7.9% silver can be soluble, okay, in the copper at eutectic temperature. So at eutectic temperature, 7.9% Ag can be able to soluble in the Cu. Okay, the solubility of both Ag and Cu decreases with decreasing temperature and around 2% at room temperature. So solubility here, it will be a maximum solubility, that is 8.8%. Here is the maximum solubility of Ag, that is 7.9%. But this solubility is decreasing up to 2%. Here it is also up to 2% at room temperature. So the solubility will be decreases up to 2% at room temperature. So this solubility will be varies from 2% to 8.8%. So at room temperature, the solubility of Ag in Cu, okay, solubility of, sorry, Cu in Ag, the solubility of Cu in Ag at room temperature is 2%, and solubility of Cu in Ag at eutectic temperature, that is maximum, it is up to 8.8%. Similarly here, the solubility of Ag in Cu is 2% at room temperature, but this solubility will be increasing up to 7.9% of Ag in Cu at eutectic temperature. So I hope you have understood this particular phases. So in the next lecture, we can be able to start with the Fe3C diagram. So that will be the very important as far as your examination is concerned. So you can be able to understood those particular diagrams very nicely. So thank you very much for the patience listening, and we will continue with the next lecture in short. So thank you very much.